All right, hello everybody. Welcome to our first video for section 3.5. Can't believe we're already along this far. We're just cruising right along. And in section 3.5, we're going to start to talk about derivatives of trig functions. So that's where this meme you see here is coming in. As we're going to take it back to good old Math 142, which I know so many of you love so much, and talk about some trig. Okay, so first thing we're going to look at here is the derivative of the sine function. And you'll notice over there on the left, I have a graph of a standard sine function, so it hasn't been transformed or anything like that. And then on the right, I have a blank graph. And what we're going to do is we're going to look at the slopes of the tangent lines at different points along the graph of sine, and we're going to use that to try to draw a graph of the derivative of sine. Okay, so first of all, before we do that, let's mark a few of the important points there on the sine graph. So we know it's starting there at 0. We see there's this peak, this first peak right here. And if you'll recall from Math 142, that happens at pi over 2. And then this place where it crosses the horizontal axis, that's at pi. And then this next dip down here, this low point, that is at 3 pi over 2. Okay, and the last place where it crosses, that's at 2 pi. Okay, so I just want us to keep that in mind as we're doing these tangent lines. Unfortunately, I have to erase that. It's going to get too sloppy, but just keep that in mind. And let's start at 0, the point 0 over there. I'm going to do my best here to draw a tangent line. And when you look at that, what does it look like the slope of that tangent line is? Well, it starts at 0, 0. It looks like it goes, if you use rise over run, it goes up 1 and about over 1. So it looks like that the slope of the tangent line at that point is 1. So I'm going to use that as a point on the graph of my derivative then. So again, we know the derivative at different points gives us the slopes of the tangent line, so that would be helpful information. So I'm going to go ahead and call this point up here. This is going to be positive 1. This will be negative 1. And we know that at 0, the slope of the tangent line was 1. Okay. Then what about at pi over 2? Well, notice that's the top of this crest here. And if I'm going to draw a tangent line there, it looks like it would be a horizontal line, which if it's horizontal, what is the slope there? Well, that would be 0. So I have a point here on the derivative. Then we'll go to pi, and I'll try to my best to draw my tangent line here. Something like this. And notice, first of all, now the tangent line is sloping down, so we know that the slope there is negative. And if we do our best to try to kind of estimate the slope, it looks like it can go down 1 and over about 1. So it looks like the slope there would be a negative 1. All right, now at 3 pi over 2, that's again where we have another little valley here, so it's another horizontal tangent line. So the slope there would be 0 again. And then at 2 pi, you can draw the tangent line there. It looks something like that, maybe. Okay, and again, we see it's sloping up, and it's kind of hard to see where it goes off the grid, but if I look at starting at this point down here, it looks like we can go up 1, over about 1, so it looks like it's another spot where the slope of the tangent line is 1. Okay, so notice I have those 5 dots there, represent the graph of the derivative, and if I connect those, actually I'm going to use this color. See, we get a shape that looks like this, and hold the phone there. Does that shape look familiar? Oh my goodness, that's a graph of a cosine function. Holy crap. So it looks like based on this, that if we want to find, if we have a function f of x equals sine of x, the derivative there is cosine. Crazy, right? Wow, math is cool. Okay, moving on. Let's look at now the derivative of cosine, and we're going to do a similar analysis here. We'll look at the slopes of the tangent lines at different points along the graph, and then use that to graph our derivative. Okay, so we start with the first one here at 0. Looks like we have a horizontal tangent line, so there the slope is 0, so we have the point 0, 0 on our derivative. At pi over 2, now it looks like we have a line sloping down. Oh, that's a pretty good drawing, actually. And if we look at the slope there, it looks like it goes down 1, about over 1. So it looks like there the slope is -1, which on my graph here, call this -1, this +1. So it looks like we would be down here now. And then at pi, we have a valley there, so that's going to be a horizontal tangent line, so we see that that's at 0. And then at 3 pi over 2, we now have a line sloping up, something like this. And I know my picture is not perfect there, but it looks like it kind of goes up 1, and the way I drew it goes over then a little bit more than 1, but hopefully you'll trust me that that is supposed to be a +1 for the slope at 3 pi over 2. And then at pi, notice again we have a peak here, so we have another horizontal tangent line. So in that case, we would see that the slope is 0 once more. Okay. So now let's connect those dots. And when you look at this, now you might have been expecting a sine function, since the derivative of sine was cosine, and hopefully you see here we sort of get a sine function, but what is different about it? Well, it goes down at the beginning instead of up. So what does that mean? Well, that means it's a negative sine function. So what we see then is that if our function is cosine, then the derivative is negative sine. Okay? And I think it's really neat, even though this one comes out as a negative sign, it is pretty cool that for the derivatives of sine and cosine, they just have something to do with the other trig function. So if you're with sine, the derivative is cosine. With cosine, the derivative is negative sine. Okay? All right, so here is the moral of the story there. So these are things that you'll need to commit to memory. And just need to know. So the derivative of sine, as we just talked about, cosine, derivative of cosine, negative sine. And be really careful. This one down here is one that folks often make mistakes with. They usually have no problem remembering that derivative of sine is cosine, but remembering the derivative of cosine is negative sine is a common mistake that I see. All right, so what about the derivative of tangent then? Well, we could draw the graph of tangent and try to draw in tangent lines and figure out what the graph of the derivative looks like. But it gets, as you can imagine, if you remember what the graph of a tangent function looks like, it is something like this, where it's kind of all these repetitive, kind of cubic looking things from left to right. And it just seems like that might be a mess to try to draw a bunch of tangent lines in there, right? So let's try a different approach. And first things first, we have to think back to our trig identities. Is there some way we can rewrite tangent? Yeah, right? So tangent is sine over cosine. Okay? So instead of then finding the derivative of just tangent, we could change this problem, become find the derivative of sine over cosine, which hopefully you can see is useful because we know the derivatives of both of those. We just figured those out. And notice what we have now is two functions being divided, right? We have sine over cosine. How do we deal with that? Well, luckily in our back pockets from section 3.3, we have the quotient rule, right? So the quotient rule tells us that this derivative should be the bottom, which is cosine, times the derivative of the top, so derivative of sine is cosine, minus the top, which is sine, times the derivative of the bottom, so derivative of cosine we just saw is negative sine, all divided by the denominator, or the bottom, cosine of x squared, right? And you may be looking at this and thinking, geez, this looks like a big mess. But notice on the top here, so we have cosine times cosine, that'll give us cosine squared. Here we have a negative sine times a negative sine, which would be a positive sine squared. So the top there has become cosine squared plus sine squared, but do y'all remember that special identity? That's right, that is the Pythagorean identity, so that is equal to 1. So what this has really become, and of course, as always, I'm running out of room here, is this has become 1 over, and then we have the cosine squared of x in the denominator is what that says. And then we can simplify this a little bit more. Remember, 1 over cosine, that's equal to secant. And so because we have 1 over cosine squared, we have a secant squared of x would be our derivative here. Okay? All right, so the punchline of all of this, I'll just delete that out. Your takeaway is the derivative of tangent is secant squared of x. Okay? Now, I'll tell you right now, if I was walking down the street, if you saw me walking down the street, first of all, at the time this video is being recorded, we're of course in the midst of the coronavirus pandemic, so you would come up to me, but you would stay 6 to 10 feet away. But if you said, hey Cody, what's the derivative of tangent? Tell me really quick. I probably couldn't tell you. I do not have this one memorized. What I do have memorized is the derivatives of sine and cosine, and I know the quotient rule, and I know that tangent equals sine over cosine, so that's what I use to come up with the derivative of tangent. This is not one that I have memorized. You're welcome to memorize it if you want to, but know you can always come up with it by using the quotient rule. Okay? All right, that's all I have for now. Thanks for your attention.